Hello everyone. This week we are going to begin learning about cartography to make you more comfortable with making maps, and we'll go further into detail later in the semester. In our cartography textbook by Dent et al., they quote Southworth and Southworth, stating that maps provide us with a structure for storing geographic knowledge and experience. Without them, we would find it difficult, if not impossible, to orient ourselves in larger environments. We would be dependent upon the close, familiar world of personal experience and would be hesitant, since many of us lack the explorer's intrepid sense of adventure, to strike out into the unknown, uncharted terrain. Moreover, maps give us a means not only for storing information, but for analyzing it, comparing it, generalizing, or abstracting from it. From thousands of separate experiences of places, we create larger spatial clusters that become neighborhoods, districts, routes, regions, countries, all in relation to one another. It has been argued that maps are one of the three major modes of communication, along with words and numbers. Maps are at the heart of geography, essential to the discipline, and have been designated as its distinctive language. Dent et al. Also quoted Carl Sauer, a famous geographer, who stated, "Show me a geographer who does not need maps constantly and want them about him, and I shall have my doubts as to whether he has made the right choice in life. The map speaks across the barriers of language." Today, I will discuss map subclasses, types, scale, elements, communication, and coordinate systems. To create accurate maps, cartographers need to have a spatial understanding of the physical environment and aerial relationships, as well as the ability to abstract and symbolize them. General purpose or reference maps include natural and man-made features of the Earth with the sole purpose of showing their location. Here is an example of a road map of Tennessee. Here is the Disneyland amusement park. Here is a state map of the United States with each corresponding capital. And here is a topographic map of Tennessee. Thematic maps, also called special purpose, single topic, or statistical maps, are the other major map type. As the term thematic map implies, they show information about a subject theme. In GIS, this is when a qualitative or quantitative attributes or variables are geographically displayed. This can include themes such as population density, average income, temperature range, among many others. The use of a single theme is what differentiates thematic maps from general purpose maps. Here is an example of a thematic map that shows the median household income for counties in the United States. And here is a world average temperature map from March 2020 to May 2020. Thematic maps are in large part the primary focus of research and analysis in GIS and geography in general. These maps are designed to demonstrate particular features or concepts by illustrating the structural characteristics of some particular geographic distribution. This involves the mapping of physical and cultural phenomena or the abstract ideas about them. Some of these features are structural and include distance and directional relationships, location pattern, or changes in magnitude of the spatial attributes. Thematic maps can show both qualitative and quantitative data. Qualitative maps show the distribution of nominal data without any quantities, and they are often very generalized. Qualitative maps focus on the differences between place to place. If you remember from a couple weeks ago, nominal data is data that does not have a number value, such as a state name. Here is an example of a thematic map that shows which name people in a state primarily call soda, Coke, or pop, or a combination of the two. Ordinal data in qualitative maps is like nominal data, where the numbers don't matter, but there are levels of hierarchy, such as low, medium, and high population density. For example, here is a Likert scale about the ability to capture condensation in the United States. Other examples include maps that show state names, different soil types, or land use or land cover. On a side note, the difference between land use and land cover is that land cover data simply states what object is on the surface, such as a type of forest. Land use data will state whether or not the tree in that area is a forest or is used specifically for agriculture. Another example is land cover data stating that the land is urbanized or primarily man-made, while land use data may state that the level of urbanization is low, medium, or high density, or it may differentiate between residential and industrialized areas. Quantitative maps show the amount or degree of the presence of a particular attribute. According to Jenks, whose name you will become familiar with when you start mapping quantitative data in ArcGIS, said that a statistical map is a symbolized generalization of the information contained in the table. Here is an example of a population density map. It includes the world data from 2020 with values ranging from less than 1 person per kilometer to over 1,000 people per kilometer. There are many different types of quantitative maps, including choropleth, dot density, proportional simple, isorhythmic, cartograms, and flow maps. Of all the different map types, choropleth maps are by far the most common and have been used in the examples that I have shown you before. In these examples, each geographic unit, such as a state, is given a color based on its value. If you are speaking with someone about a choropleth map, make sure you use the correct pronunciation. Say choro, not chloro. Chloro is the root word for pale green, like in chlorophyll, while chloro is the root word for location. It's a pet peeve of some geographers and cartographers, and it's something that I struggle with, so please forgive me. Dot density maps are used to model spatial density, where each dot is given a certain value, say 1 occurrence of a COVID-19 case, but they could also be another number like 10 cases, and each dot represents the assigned value or the value ranges. So if there were 10 cases of COVID-19 in Knox County, and each dot represented 1 case, there would be 10 dots shown in Knox County. If there were 10 cases in Knox County, and each dot represented 10 cases, there would be 1 dot shown in Knox County. Be careful when creating and analyzing these maps because points can easily overlap and inaccurately represent the data. If you manage to get your hands on health data that shows the points for each case of a disease, make sure you understand how that data was created. It could have originally been created as a dot density map where the table had a single row with a value of 10 for the number of cases in Knox County, and so then it created 10 randomly placed dots. It could also have been created where each case was shown as a different object or different row in a table, and they have the addresses of each infected individual. Unless you work in healthcare at a location where you have patient addresses, like a hospital, it's unlikely that you will have access to this data because of HIPAA privacy laws. Data that has a different row for each individual is unlikely to be displayed with each person's actual address. Instead, an algorithm is used that randomizes the location of each person on the map and it displays the altered location. If you are analyzing this data as a dot density map, it should not be a problem. However, you should never use these locations as actual locations during an analysis. In dot density maps, all symbols are the same size. However, that is not the case in proportional simple maps. Proportional simple maps use symbols that are scaled to certain values and are usually represented as a circle. Unlike dot density maps, each feature only has 1 symbol. Isorhythmic maps attempt to show continuous values such as elevation, temperature, or precipitation. This is done through the use of isolines. Isolines are lines that connect points of equal value. If you have a point-shaped file of different continuous values, you can easily transform that into an isorhythmic map. Cartograms replace the geographic unit with a symbol that represents the variable values. It can also change the shape and size of the geographic unit to represent the variable values. Lastly, flow maps show the linear movement between places. The difference in line thickness and color indicates a change in the flow or movement magnitude. Map scales range from large to small. The naming of large and small scale maps are confusing, so pay attention to the amount of detail rather than the amount of area displayed in the map. Large scale maps show small areas, allowing for large amounts of detail to be shown. Small scale maps show large areas of the Earth's surface, so smaller amounts of detail can be displayed when compared to large scale maps. I listed some general guidelines on the slides for how to tell the scale level. Every map needs a base map, a thematic overlay, and a number of other map elements for context. The purpose of the geographic base map is to give the map reader information about the location they are looking at. The base map should be kept as simple as possible to give the reader information they need while not distracting them from the overall message. The same is true for the primary information that you are trying to display. I'm sure many of you have heard of the KISS rule. I first heard it as keep it simple stupid. My advisor said that it should really be keep it simple smarty, but then I read it as keep it simple scholar, and I think that fits best. It's important to keep everything as simple and as clear as possible to avoid any confusion or visually overwhelming the map reader. KISS also applies to the additional map elements. They should be kept simple and used to visually balance the map. The title is important to let readers know what they are looking at before they even look at the rest of the map. The legend is important because without it, all you really created is a pretty picture. In order for your map reader to accurately understand what's going on, legends are required. Keep in mind that most people nowadays are familiar with apps such as Google Maps, but those don't cover the depth of the information displayed in most thematic maps. Legends help the map reader correctly interpret symbols, value ranges, aggregation levels, and so on. Aggregation levels are the level that the information was generalized at. For example, your map could show population densities of blocks, cities, counties, states, or countries. Remember that not everyone looking at your map is familiar with the area you are showing them, and they need additional information to best understand it. Including a scale is important because your map is just a piece of the world that can be zoomed into or out of at any level, which is unknown to the map reader. There are many different types of scales you can use, and we'll talk about that more in a few weeks. The same is true when it comes to the compass. You can change your map to face any direction you want, and unless you know which way the map is orientated, the reader will not know. In the Northern Hemisphere, it's customary for the northern direction to be at the top of the page, but that may change depending on how your map best fits or the purpose of the map, and it's completely up to whoever created it. The neat line is a frame placed around the extent of your map. When I was taking an introductory cartography and GIS course, my professor told me that if you do not include a neat line, it is as if your map is floating around in space because it is not contained. Lastly, always include your sources. Geographic data is difficult and time-consuming to collect, not to mention the process of transforming it into a digital format and making it available for other users. Those people deserve the credit for the work they put in. However, unlike formal citations in writing, you will simply list the source name and the year it was created in the list, and place it somewhere, usually on the bottom of your map, in small print. Also, give yourself credit for your analysis and the artwork you created by adding your name and the year that you created the map. Before I begin talking about the information on this slide, I know you're all going to have a number of questions about it. We'll go over it in more detail a bit later. I just wanted you to familiarize yourself with some terms you may see to avoid total confusion until we get a chance to really discuss it. If you want to know more now, your textbook is a great resource, and there are many videos and websites that can help you out until then. Because the Earth is not perfectly round, mathematical estimates are used to measure the surface of the Earth. Geodesy is the science of measuring the Earth. Depending on the algorithm used, the size and shape of the Earth can differ dramatically. A datum determines how the size and shape of the model Earth comes out, and is based on a common point between the Earth's surface and the geodesy model. Grids are used to determine coordinate locations. There are two types, Cartesian coordinate and geographic grids. And they differ in that geographic grids are based on a sphere, not a cube or rectangular prism. The Cartesian grid has an X, Y, and Z axis, while the geographic grid has lines of latitude, longitude, and a z-axis. Lines of latitude run parallel to the equator, with the lines of longitude running perpendicular to those. The way that I remember the difference between the two is that lines of latitude are drawn like you're climbing up and down a ladder. Map projections are the way in which the 3D Earth is transformed into a 2D format. Because models are being used, there will be some level of distortion. The type and severity of the distortion is dependent on how you projected your map. In order to effectively communicate with your map, you must know about your audience. This is particularly true when it comes to color. A few years ago, I went to one of my best friend's sister's wedding. Let me start that again. A few years ago, I went with one of my best friends to her sister's wedding. She moved to the US when she was 1 with her family from India, and they practiced the Sikh religion. If you know anything about Indian weddings, you know there are a ton of events to go to in addition to the ceremony and reception. The amount of events increased because her sister was marrying a Catholic Hispanic man, and they had separate weddings on different days for both faiths. This required many outfits. I know this is boring to some of you, so please bear with me, but there is a point to the story. My best friend wanted me to wear a traditional Indian outfit for the Sikh wedding and let me one of hers, so that problem was solved. In many cultures in America, it's customary for the bride, and only the bride, to wear white on her wedding day, as a representation of purity and happiness. Anyone else wearing white is seen as an insult. On the other side of the spectrum, black is often worn to funerals as a symbol of sadness and mourning, which could also be seen as an insult if worn to a wedding, not including men's formal wear. However, the opposite is true in some Indian cultures. White is seen as a symbol of sadness and mourning, while black is a symbol of happiness and celebration. That was good news to me because black is much more flattering and definitely my color. This may change the way you create a grayscale map. In terms of map making, the use of red is particularly important. In the United States, red is often associated with being bad. However, in many Asian cultures, red represents happiness and wealth. Red is also the most difficult color for the colorblind to differentiate between, especially when used in combination with green. Lastly, the location where your audience resides or is from will change how the map is displayed in red. Maps that include multiple countries are often centered on where the author is located, with the rest of the map being oriented around it. This is also true when it comes to the orientation of maps with countries located in the Southern Hemisphere. They are more likely to have south be at the top of their map than the north. It has been debated forever whether or not cartography and geography in general is a science or an art. As with most things in life, it's not black and white. They are not purely art or science, but a combination of the two. Cartography is not just an art because there are rules and methods that need to be followed, but some decisions are left to the cartographer, making it an art. That's all for this week.